All right. We're doing some stuff on paper. Seriously, people. So what we're going to do is we're going to look at number 20 on here. So all of our numbers are going to be a little bit different, but you should be able to see it on the top of your screen there. So we've got ourselves a multiple batteries. Okay, I got V1 and V2. We're going to use both of Kirchhoff's loop rules. So there's one that deals with current, that the current splits and recombines, and the second one that deals with potential, that the potential for a loop will equal 0. So we're going to use those two ideas. So we're going to start with current. So I1, the 3 is getting me, plus I2 combine to make I3. So I3 equals I1 plus I2. Since our numbers are different, I'm going to keep my variables as long as possible. Second thing we do is we look at a loop. Now, there's no wrong way to draw a loop. You just have to draw a loop. But we're going to do the outside one first. So we're going to do the outside loop first. So the far outside loop, we're going to write out what it has. Starting on the positive side of the terminal, I have a positive potential that will raise it, but then as it goes across the resistor, it will drop. It will lose potential. So it's I1 going through it, R1, and then as it goes here, there's no resistors. We're good, we're good, we're good. V2. Well, that battery's in the same direction, so it's going to gain potential. If it was opposite direction, it would subtract, but if you have them together, they add up. When it gets here, it's going to drop across that. So the current is I3 that goes through here, so minus I3 R3, and we're back. And that whole loop will have a potential difference of 0. Now in my work, I can now plug in. I1 is 3, R1 16, V2 is 14, I3 is unknown, R3 is 2. Okay. So that's one loop. Let's get another loop going on. So another loop is, let's do this one. So starting on the positive side of the terminal, so the right loop, I've got V2, but then it drops across this one, which is I3, R3. Then as it gets here, it's going to drop across this one. The current through it is I2. So it's minus I2, R2. Comes back, there's nothing else on its path will equal 0. So if I write out the work for that one, I3 times 2 minus I2 times 8. Now, here's the key. Up here, I have I1 equals 3. So I'm going to go here. So that means I3 equals I1 plus I2. Now, if I were to take this one and combine it into this one, I know what I3 is equal to. So if I plug in, there's I3. I3 is equal to 3 plus I2. So now, distribute the 2 and the negative through. So I get minus 6 minus 2I2 minus 8I2. I just put the 8 in front. Equals 0. So now I have 8 minus 10I2 equals 0. Solve that out. Now, you're saying to yourself, this is insane. Well, watch this. Now you can come along and take that quantity stick it in there. Now you know I3. All right, take those quantities, stick them into here, and now you know V1. So the key is, as you go through this, you're always going to be using two of Kirchhoff's loop rules of current and potential. And then you're trying to find, okay, what's an equation with the least number of variables? How can I get rid of one? And then you're on your way. So again, this is multiple batteries. In terms of the AP Physics C exam, I would expect to see at least one every year. We'll look over the FRQs to see how regularly they come, but always be prepared for this, but realize this is probably as difficult you'll see in our class, but I hope this helps. All right, thanks for tuning in.